All right, good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of tutorials. If you haven't already, subscribe to the channel and leave a like for this video. Now, in today's lesson, we're in complex analysis. And basically, we're going to look at how to draw paths of integration. So we have path 1, which has t plus it, and it has limits from 0 to 1. Okay, so now the easiest way to draw these paths is to make an equation out of the paths. And for you to make an equation, you need to consider the fact that a complex number z can be written as x plus I y. Okay, where x is the real part, y is the imaginary part. So what we're going to do is, for the path that we've been given, so in this case we have x is equal to t and y is also equal to t, the imaginary part. And we can combine these two by making t subject to the formula and replacing there. So we see that we have the equation x equals to y. And if we did not have limits, the equation x is equal to y, we just draw it straight like that. We know how to sketch the equation x is equals to y, but we have limits. So we have where the equation is starting from and where it is ending. Okay, so we need to include the limits there. So this is the equation. So, but if we include the limits, so let me just cancel this. Okay, if we include the limits, when t is equal to 0, which is the lower limit, when t is equal to 0, we see that our x, which is equal to t, will be 0, and our y, which is equal to t, will also be 0, meaning that the first starting point is 0, 0. Okay, then the upper limit, when t is equal to 1, we see that our x will be 1 because t is 1, and our y will be 1 because t is 1, and our end point is 1, 1. So the starting point of this line, x equals to y, is 0, 0. So I can put on 0, 0 here, 0, 0, and its endpoint is 1, 1 there. And we can draw the line x equals to y from there to there. And we can simply put the direction going up like that. So that is the line 1. So we can even label this as lambda 1 of t. Okay, so, and we are done. So that is the first part. So same thing with the second part. So we're going to use we're not going to use the same xy plane. So let me just clear the plane out and everything. All right, now we are on the second path. Again, the same thing. We know that a complex is written as x plus iy, where x is the real part and y is the imaginary part. So in this case, the real part is this part. So our x is equal to 1 minus t, and our y is the imaginary part, which is this, and our y is also equal to 1 minus t. So here you can make t subject to the formula and replace there. So, but again, we see that this and this are the same, so we can just equate them, and we're going to have again the equation x equal to y. So again, if we did not have limits, the equation x equals to y is that line. So, but we have limits, so we need to follow those limits. So let's consider the limits here. So when t is 0, so when t is 0, this is okay. When t is 0, what is the limit that we're going to have here? So when t is 0, our x is equal to 1 minus 0. So that will be 1. And when t is 0, y is equals to 1 minus 0. So we see that for the lower limit, in this case, we're going to have 1 comma 1. That is for the lower limit. Then when t is 1, we see that here on y, where we had 0 here, we're going to have y is equals to 1 and x. Okay, so when t is 0, we're going to have 1 minus 1. So meaning that our x will be 0. So 0 and our y would be 0, 0, 0. So this is the starting point and that is the ending point. But the equation is this equation here. So the starting point is 1, 1 here. And the ending point is there. So we need to put an arrow to show the direction that we're descending. So from here going there. So we already know how to draw the x equals to y. So now we can just put an arrow to show that the line is descending. So this is lambda 2 of t. Okay, so that is lambda 2 of t. So basically that is the case. You just need to convert the equation into x and y and you sketch it. Okay, so now we go to lambda 3, which is this part here. So we're going to do the same thing. Let me just erase the board. Right, so for path 3, we have path 3, which is equal to 2e to the negative it, which we can write as I, then negative t. Okay, and basically we know that a complex number can also be written as z, which is equals to r e to the I theta. Okay, which can be simplified as r cos theta plus I r sine theta. So we know this fact, so we can use this fact to sketch our next line. So again, this is your x and that is your y. So the same thing, we can do the same thing on this equation here. Okay, so we can say, actually there are two ways to draw this. So I'll show you the first way, which is converting to rectangular, because we already have a rectangular xy plane here. So we have our path nabla of 3, nabla of t, which can be written as 2 e this, so it will be which can be written as 2 cos negative t. So the negative t is representing theta plus I sine negative t. So we have that there. Okay, so now having that negative 2t here. Okay, so we're distributing the r, which is 2. So we know that this is representing x. So x is equal to 2 cos of negative t. And this is our y. There's an I there. So y is equals to 2 sine negative t. So these are our y and x values. Now we know that cos squared theta plus sine squared theta is equal to 1. So what we can do is we can try to make this part squared and this part squared so that we can replace in this formula here. So what we can do is we say we can square both sides of this equation. We're going to have x squared is equals to 2 squared, then cos squared of t, of negative t. then we're going to have y squared equals to 2 squared sine squared of negative t. Then here we can introduce a 4 here, a 4 there, and a 4 this side, so that we have this, which is the same thing as this, and this, which is the same thing as that, because 2 squared would be 4. So we can just replace this here, and this can be replaced there. And we're going to simply have the equation x squared plus y squared. When we replace this with x, x squared is equal to this with x, y squared, and this will just be equal to 4. And what we have here, ladies and gentlemen, is the equation of a circle, which is in the form x squared plus y squared equals to r squared. So the radius squared is equal to 4, and the radius of this circle is 2. So we can draw this. Now remember, this is a circle, but we have limits on this circle. So the circle is from 0 to pi. So from 0 to pi, this signifies that it's a semicircle. So we have the circle, let me just write it here. So the circle is x squared plus y squared equals to 4, and the radius is 2. But we're moving from 0 to pi. So meaning that we have a semicircle. So I can just make a simple sketch here of the circle. So the radius is 2. So meaning that it will be from here, from 0 to 2, that is the radius, from 0 to 2, that is the radius, from 0 to 2, that is the radius. So this would be a semicircle, and I can get my compass and draw. All right, so that is my compass. I can simply draw a semicircle like that, and I am done. Okay, so this is the semicircle for lambda 3 of t, and we are done. Okay, so that is how we do that one. So we can do the same thing for the other question. So let me clear the board out. All right, so let's look at this question. Again, it's the same thing. So we have, which can be written in this form. So we have, we know that z is equals to r e to the I theta, which is just equals to r cos theta plus I r sine theta. Okay, so that is our z. So we can see that our r is 1. So meaning that our z would just be equals to cos of theta, which is t. Just say cos of t plus I sine of t. And basically y is equals to, can start with x. X, the real part is cos t, and y is the imaginary part, which is sine t. Then same thing, we can use cos squared theta plus sine squared theta equals to 1 to combine these two. So if we square both sides, so we're going to have this squared, this squared, this squared, this squared. We'll see that x squared is cos squared, so we can replace it here. This will be x squared plus y squared is sine squared, so this is y squared equals to 1. Then we can simply see that this is a circle with radius 1. We know that r squared will be equals to 1, and r will be equal to 1. Okay, so but this circle has limits from 0 to 2 pi. So 2 pi, I mean pi over 2. So pi over 2 is 90 degrees. So we see that this is a semicircle from 0 to pi over 2, which is 90 degrees. So in drawing our circle, we can come here. So now we want to draw the circle. X squared plus y squared equals to 1. The radius is 1. So we can get our compass and minimize our radius to 1. Let me zoom in. So minimize the radius to 1, if that is even possible. Okay, let me just draw the now. Minimize the radius to 1. So it is starting from okay. All right, so when we sketch our half circle, it will be somewhat there. And we are done. So this is our the 4 of t. And that is how you sketch paths of lines. Okay, see you in the next lesson.